Chapter 46, Tires and Wheels. So what are our objectives? Describe basic wheel and hub design, recognize the basic parts of a tubeless tire, explain the differences between the two types of tire construction in use today, and explain tire ratings and designations in use today. Describe why certain factors affect tire performance, including inflation pressure, tire rotation and tread wear. Remove and install wheel and tire assembly, dismount, remount a tire, and repair damaged tire. Describe the difference between static balance and dynamic balance. Balance wheels both on and off a vehicle. Describe 3 popular types of wheel hub bearings. So, wheels. Wheels can either be steel or aluminum. If they're steel, generally they're stamped pieces of steel that are either riveted or welded together. Generally, steel wheels are less expensive and less desirable. Wheel sizing. So if we're talking about a wheel size, generally we're going to be talking about the rim diameter as well as the width. These are generally measured in inches. Offset. So another thing to consider when buying wheels is your wheel offset. So wheel offset is basically talking about the mounting flange, where the wheel mounts to the hub. With a 0 offset, it's going to be right down the center line, centered on the rim. Having positive offset, essentially we're tucking the wheel in and the mounting flange is closer to the outside of the rim. Negative offset, so we're sticking the wheel out. Here's a better way to vision it actually. So positive offset, sucking the wheel in. 0 offset, more of a centered. And then negative offset, kind of the cooler one. We're going to have some tire poke. If we want to have cool stance, we'll go to more of a negative offset rim. Basic parts of a tire that will include the cord, body, or casing, bead, tread, or crown section. Casing consists of layers of rubber-impregnated cords called plies. They are bonded into a solid unit. The bead is a heavy band of steel wire that helps keep the tire in contact with the rim of the wheel. So it's actually a whole bunch of pieces of wire, essentially, steel wire that wrap around the bead. Tread portion is the part of the tire that is in contact with the road surface. A couple different styles of tires, or tire construction. Either we're going to see it's a radial tire or a bias ply tire. So bias ply tires are way less common. They were kind of the original design. You still can get bias ply tires, more so for trucks, 4-wheel drives, or specialty. Maybe some drag racing tires would be bias ply. Possibly not. But the difference is essentially on the inside. So if we look at the plies, on a radial tire, they're just all going in one direction. They wrap around, looking at the orange here. And then on a bias ply, they run on a bias or an angle. So they overlap on different angles. And apparently this angle can vary from 30 to 38 degrees with the tire center line. Something to note, don't mix bias ply and radial tires. Not so common we're going to see bias ply tires these days, but they do have different handling characteristics. So make sure we either have 4 bias plies or 4 radials. All season tires, designed to perform well in all types of road conditions, but they are not excellent performers on all road surfaces. To provide traction in the snow and mud, at least 25% of the tread area is void to allow snow or mud to remove as the tire rotates. Self-sealing tires. So if we get a nail in our tire, we don't want it to go flat. There are what's called self-sealing tires. Essentially, they have an inner layer of goo, technical term there, that if you get a puncture, if the nail were to pull out, it's self-healing. So this sticky inner membrane will actually reseal itself. Apparently, we can get punctures up to about 3/16 of an inch. So that's a pretty good size hole. The downside of these is repairing them after. If we were to get a larger hole, or maybe it didn't actually seal itself. It's kind of impossible to repair as they have this membrane on the inside. Self-supporting tires. So another name for these, or a more common name of these, is run flat tires. They have a much stiffer sidewall. So generally when you get a flat tire, and if you're trying to drive on a flat tire, what happens is as the weight of the vehicle pushes down, generally the rim is going to pinch the sidewall. It generates a lot of heat. There's a lot of distortion in the tire, and usually what happens is from the inside, the sidewalls wear through eventually if you drive on it long enough. So with the self-supporting or run flats, they have a stiffer sidewall, which does allow you to drive on a flat tire. Generally, they'll give you a certain distance you can go and a certain speed you can go without wrecking the tire. Auxiliary supported run flats. So these are kind of cool. They've actually got a insert in the tire so that if you were to get a flat, it's not going to go totally flat. Sorry, if you were to lose air pressure, you can then run on this inner ring here. I can't say that I've ever seen one of these on a vehicle. It doesn't look like it would be very much fun to change one of these tires. So what if we get a flat tire? Well, we should be able to repair the tire. This is just showing what's called a patch plug is a more common term for this. So it requires removing the tire from the rim. Generally you buff or sand out the inside of the tire, put on a glue, and then you can pull this patch plug through the tire. And generally they're really, this is the proper way to fix a tire, let's say. Directional tires. So directional tires are only supposed to go in one direction. This one is quite evident that it's directional. Essentially, if we look at it, it looks like an arrow pointing forward is the direction you want to go. Often we would see direction written on the outside of the wheel, or an arrow which way it's supposed to turn. All kinds of stuff we can see on the sidewall. So these markings, they're not just random numbers and letters. I'm not going to get into this too deep. There are sort of certain ones that are important, more so for tires. Aspect ratio, 65%. Actually, let's just go to the next slide. So a bit easier to understand here. P195 80R14. P stands for passenger. Other ratings we might see are T for temporary, C for commercial, and then as well LT for light truck. Next we have our width. Our width is in millimeters /80. The 80 is the aspect ratio. So aspect ratio, we'll get to in the next slide, but is basically our sidewall height or a section height. And R is the construction. R for radial, could be a bias ply or a diagonal bias ply. And then finally we have our rim diameter, and this is in inches. So something unexplainable, why do we have a mix of metric and standard? One of life's many unsolved mysteries. So aspect ratio or profile or series of a tire is its cross-sectional height compared to its cross-sectional width. So it is in a percentage. So on this one, our 60 series, our profile or height is 60% of the actual width. Here's a 50 series, it's 50% of the width. So lower the number, the lower the profile, or thinner this area is. So sports car, we're gonna run maybe 40 series, 35 series. If we have a big truck, we might go up to a 75 or an 80 series, so to give us more cushion. Speed ratings. So you don't have to memorize this chart. What you need to know is lower in the alphabet is for slow speeds, higher in the alphabet for high speeds. So one thing that's kind of interesting here is a Y-rated tire actually has a higher speed rating than a Z rating. So my guess is they made this chart a long time ago and thought Z was going to be the highest. Then they made a tire that was even better, so they replaced it with a Y. But anyways. Tire placards or safety compliance certification label. most new cars, well, I'm going to say all new cars, they're going to have a sticker in the driver's side door jamb. It will give us a tire information, tell us what size tires are supposed to be on the car, and more importantly, what inflation pressure. So what if we have incorrect tire pressures? So we can get abnormal wear. So if we look at an overinflated tire, generally it's going to balloon the tire, which is going to cause the center of the tread to wear out. Running an underinflated tire, it's going to be kind of crowned like this, and it will wear the outsides of the tire. Some other things we might see are cracked treads from an underinflated or over excessive speed, so overheated tire. I don't know about that. Inflation pressures. So sometimes imported vehicles are given in kilopascals, kPa. Maybe we need to convert to PSI. We can use this handy table. To equalize tire wear, most car and tire manufacturers recommend that tires be rotated. This is important. So depending on the vehicle, front and rear wheel drive, there are different ways we can rotate the tires. So the most simple way is just swapping front to back. However, depending on if we had different size tires. So some cars are going to have wider back tires, so we don't want to do a front to back. We can just swap them side to side. If we had a full-size spare tire, we could actually rotate this in when we're doing our tire rotation, so all the tires actually end up getting used. I don't know. Easiest one is probably front to back. It kind of depends on if we're seeing abnormal tire wear. Maybe the vehicle is pulling to one side, might decide which way we want to rotate the tires. Our tires worn out, we can use a tread depth indicator to measure our tread depth. When only 1.5 millimeters is left, it's time to replace a tire. Yeah, this is good advice. TPMS, tire pressure monitoring systems. So, most commonly used tire pressure monitor system is referred to as a direct system. What this means is there is a tire pressure sensor, usually incorporated with a valve stem mounted inside the wheel. This sends a signal to a computer which monitors our tire pressures. It can also monitor, usually it gives us tire temperature as well. Not that that's really that important to monitor. TPMS light, so how do we know if there's a problem? Generally, we're going to have this light come on the dash to tell us that there's a problem. First thing we would probably want to do before we bust out the computer is actually check our tire pressures. If our tire pressures do seem to be the same, we would then actually have to use a scan tool to connect to the OBD2 port and diagnose the TPMS problem. What would be some of the problems? Quite often, the sensors go bad would be the most common. When we're installing wheels, so we want to make sure we tighten them in a star pattern. This is so that it draws the wheel evenly against the hub. They also need to be tightened to a certain torque spec. This is going to avoid distortion of the wheel and, well, hopefully keep the wheel from falling off. Couple styles of lug nuts. So this is important. We have what's called a plain boss or a tapered boss. Tapered boss are going to be the most common. Plain boss, this is more used. Toyota uses this. So we need to make sure we are running the correct lug nut. On a tapered boss, it's this actual tapered seat, which is gripping into the wheel. Whereas on a plain boss, they just have this flat. That being said, the rim has no provision for a tapered boss. Talking about plus sizing tires, a way to change the contact area of a tire without affecting its overall diameter. So let's say we want more grip. We want to put a wider tire on the car, but we don't necessarily want to have a taller tire. There are ways to calculate this. There are what's called plus sizing charts, which will tell us basically our overall diameter, etc. Wheel run out or tire run out, more wheel run out, what we're measuring here. Maybe we have a wobble in the car. We can actually check to see if it's a run out in our rim or a wheel, or do we have a bent rim? Maybe we're drifting and smoked a curb. Not that we would ever do that. So we can use a dial indicator, spinning the wheel. We can actually measure for run out. So we can check radial run out, the in and out, or we can measure vertically run out. Often it's easier just to do this, well, not easier, but we can always see this when we have the wheel on the tire balancer. Spinning it, you can quite often see imperfections in the, or run out in the wheel. Balancing wheels. So many equipment manufacturers recommend static balancing. So static balancing, I'm not going to say that's recommended. That's kind of a thing of the past. What is a static imbalance? So static imbalance is basically talking about an up and down movement of the tire and wheel. And then more what we're going to actually look at, or sorry, what we're trying to correct generally now is dynamic imbalance. So it's kind of the weeble wobble or the in and out movement of a wheel. How we go about checking this, kind of the same way we're going to use a tire balancer, but doing a static balance, generally you're only going to place weights on one side of the wheel, whereas on a dynamic balance, you're going to be putting the weights on the inside and the outside of the rim. Most tire machines will give you the option too, to go with a static or a dynamic. So wheel balancers. This is kind of a cool one. This is what's called a road force one. So you can see it actually has this extra drum, which is going to come down and ride on the tire as it spins. And this will show us for more so run out problems. If the wheel is moving up and down, this drum will actually measure that. Much nicer display too than, say, kind of a conventional wheel balancer. Wheel bearings. So wheel bearings, a few different styles. What do we got here? We've got some tapered wheel bearings. Often front wheel hub bearing assemblies for driven and non-driven wheels is actually two tapered bearings facing each other. Each of the bearing rides in its own race. Some are sealed units that are lubricated for life. Pretty much the most common ones are, sealed units now. And some are actually serviceable. So in this picture, it is a serviceable one. So serviceable one, use this special tool for removing the dust cap. Not channel lock pliers or a hammer and a chisel, because everybody has this tool in their toolbox. Remove the wheel bearings from the vehicle, wash them out with solvents. We can then inspect them for wear, repack them with grease, reassemble. Sorry, this slideshow is pretty vague. Adjusting wheel bearings, this is important. So always go by manufacturer specifications, but generally we want them to, we want the hub to have not very much end play. So what are their specs here? They're saying 1/1000th of an inch to 5/1000ths of an inch. Kind of a side profile showing our wheel bearings here. So our spindle, our inner bearing and our outer bearing. Generally the inner bearing is larger diameter. I'm not entirely certain why. Probably takes more load. Make sure we use the correct grease. So this is important actually. You do want to make sure it is a wheel bearing grease. And quite often we'll see wheel bearing grease for disc brakes. So disc brakes run hotter. We want to make sure that that grease isn't going to break down. That was an awesome chapter. I'm kind of tired of tires.